All right, well, welcome everyone to the 155 showing of Ant-Man and the Wasp. We should. So thanks for coming out to the Metreon here. So this is proactively restocking inventory using machine learning. My name is Sundip Parikh. I am part of the Google Cloud Solutions architecture team. And so with that, why don't we get started? So what we're going to cover today, first I want to walk through kind of a basic challenge that we see often in retail and in inventory and keeping that stock out. Want to walk through a few of the kind of modern approaches that people tend to take when trying to solve inventory challenges. And then we'll figure out how we can build a system to solve for this problem. Right? What are some of the components we can use to address sort of the inventory scenario? And we'll kind of map that back to the components inside of Google Cloud Platform and what an architecture might look like in production. And I'm hoping to showcase a little bit of a demo as well before we get to the end. And then finally, I want to close on questions. And just so you know, there are mics at the ends of both of the third or fourth aisle here. If not, if you can't get out there, just try to shout, and I'll repeat it so that others can hear it as well. So what's the problem we're trying to solve in this example? Right? It's produce, bananas in particular. So specifically, what we're trying to do is keep bananas in stock on the floor, all right, on a grocery store floor. You can imagine a produce section inside of a larger store. We're trying to keep that in stock. Now, we can't leave too many out on the floor because, obviously they'll go bad. But if we wait too long to restock them, we'll lose sales, right? And you also risk that kind of inventory loss by leaving it in the back room for too long as well. So this is a pretty high turnover sort of use case where a lot of product needs to move off the floor relatively quickly, but we need to restock it just as fast to make sure we're not missing out and we don't have to get rid of anything, right? This is a perishable item. And you can sort of map this to several different use cases, but in particular, I think produce is a good one. It's a good fit for, or a good stand-in for kind of a low margin, high turnover item. So how do folks typically solve inventory challenges today? And not just produce, but sort of broadly around inventory challenges. So there's typically three main components in these scenarios: RFID, cameras, and people. And if we unpack each one of those, we kind of figure out that it's not a perfect fit for this kind of produce-style use case. So with RFID, there are typically two main approaches, right? You have active tracking or active scanning, and that's where you've got a handheld scanner, and you're walking up and scanning, rough areas of individual items. The second approach is passive scanning, and passive requires you to install antennas up on the walls or in the ceiling, and then you basically blanketing an area with scans of RFID, and you're waiting for the responses to come back. Both of them have their own challenges, and ultimately, the costs don't really line up, again, with high turnover, sort of low margin items, right? You're not going to put an RFID tag on every banana, or every head of lettuce, or every pack of gum that's in there. And it also requires a lot of significant investment in both cases. In terms of the handheld scanners, it's a little bit more manageable, right? Because you can actually outfit several individuals, and they can spend their time kind of just roaming around the space, scanning for items. With passive tracking, you don't need to send people out, but there's a high cost for the antennas, right, and the antenna placement, and there's also a high cost to actually correlate each of the readings and figure out what's accurate, right? For passive tracking, the accuracy is a little bit more difficult right out the gate, so it does require an additional investment to really get to the same level of accuracy that you might get out of a handheld scanner. But like I said, ultimately, the problem is that the costs don't match up well. Now, what about cameras? Cameras are plentiful, right? They're pretty inexpensive, relatively speaking, especially compared to something like RFID out the gate. And they have pretty good resolution. And they actually have kind of a dual purpose, right, or multi-purpose. You can use them for security footage as well as watching stock. But there are some caveats. So with stock, you're probably only going to get kind of an overhead view of the world, right? You're not going to get down to sort of shelf level. So it's not a great solution for every single kind of stock or inventory use case. And again, you can imagine, like I'm thinking of like a grocery store in my head. But ultimately, the problem with cameras is that they require somebody actually evaluating the footage that's coming off of them. You effectively need someone or something monitoring them to decide what to do. Which brings us to the third kind of approach, and I think one of the harder challenges as well, which is people, right? In both cases, if you've got active RFID tracking or you've got cameras deployed, You need people there to actually administer and operate this mechanism. And people are hard to scale, right? You've got to hire a fair amount of people to get folks turnover, get enough coverage in terms of holding the scanners or watching the camera footage across a number of different cameras. They're also hard to train, right? You're not going to keep training more and more people. But ultimately, the biggest problem is that you end up with a lot of wasted cycles. You end up having a lot of people who might just sort of be standing around, and as much as I would love to be paid to stare at produce all day long, it's not terribly exciting. So one of the things we can do is we can make smarter cameras. That's a great way to do this. Now we have a camera on the front end, and we have a pretty powerful brain behind it, and that's how we can solve this problem. And really what you get down to is a pretty simple technology on the front end for kind of capturing the data that we need to gather, but we still need a scalable technology behind it to analyze that footage. All right, so we kind of laid out the challenge. We've kind of covered a little bit of the approach. Now, we know what our challenge is, right? So let's figure out what are the pieces we need to make this work, right? At a high level, let's talk about the kind of the major pillars here. So there's 5 major pieces. The first are cameras. Right? That's kind of a solved problem. We've kind of figured out that those are going to be there. We also need a scalable storage mechanism to store the footage that we're going to pull off of those cameras. Then we need some kind of a classification mechanism. Images, video, something to put that brain behind the camera footage. And then we actually have to finish this up and say, how do we notify a store associate or a team member on the floor and let them know that they've got to go restock the item in question? And then the final piece in the middle there is orchestration. How do we get this whole machine humming and running and operating on a regular basis? So the bottom sort of 4 components are the ones that we can do inside of Google Cloud. So you can imagine you've got cameras deployed at the store, right? Those need to actually push those images up to a storage. The classifier will pick up those images, classify them, figure out what's in them, and then based on what they see, they'll send a message out to the team member. So all that we can do, and that orchestration component that runs it all of that can run inside of GCP today. So just to quickly recap here, right? Cameras are plentiful, right? They scale up from consumer class to commercial class. You can find them in all manner of different resolutions, or black and white or color. You can get really cool fisheye ones that are mounted on the ceiling and pan and zoom. There's an endless array of cameras. Trust me, I looked before the talk just to see what was out there. And you actually have the option of streaming or sampling that data, right? The thing to remember here is that if you imagine a scenario where you've got hundreds of stores, thousands of stores, streaming video off of every security camera back up to cloud infrastructure, technically speaking, not terribly difficult, but from a bandwidth and cost perspective, again, you're getting into that equation of, do the costs line up with what I'm trying to solve for? So you may not necessarily want to overinvest in network bandwidth to stream video when sampling every minute with a 2 megapixel image could be just as sufficient. Once you get into the cloud side of things, that's where we need storage, right? We need a scalable object storage platform to store this data coming in. So we would have the kind of camera upload that data, and you need a little bit of a local device or kind of a control plane there, something that's on the store side to capture and sample the images, package them up, and then send them to cloud infrastructure. And that local device can be anything from, I've seen people deploy things like single board computers like a Raspberry Pi, all the way up to like rack mount servers. It really just depends on the sort of size and scope and the number of cameras you've got there, and effectively how often you're sampling as well. All right, what about a classifier? It turns out building an image classifier is a non-trivial exercise, right? You need a lot of data science expertise and understanding to train a model and to build and train a model. And then you need a fair amount of ops expertise to really deploy and scale that model, right? And run it for, again, a production use case like this. Again, think of the model of a lot of cameras across a large store, a lot of team members, and now multiply that by 100 or 1,000. Right, that's a lot it's got to process through and understand, so it's going to have to be very scalable and production ready. Well, how can we make this easier on the Google Cloud side? That's where the Cloud Vision API comes in. The Vision API, imagine this as a turnkey, pre-trained model. All you have to do is give it images, and what it gives back to you are everything we find in the image. That could be any kind of classification, any sort of object detection, face detection. It can actually read words as well. It does OCR. It has OCR capabilities. So anything you need to sort of pull out of an image, right, is possible with the Vision API. Anything you need to learn. And it can do a lot of complicated things like, for example, if you have sort of two objects in there, it'll tell you the color, it'll tell you the percentage of those colors as they occur within that image. So you have a lot of capability here, and it's a really easy API to get started with. But what if that's not enough either, right? You can imagine a scenario where, well, what if you have a very particular use case or a very particular setup, and you need a little bit more than just what the stock Vision API gives you? And for that, we actually have something called AutoML. AutoML is an effort that started out of the Google AI team, right? The research team inside of Google. And their focus was really on building machine learning models. And I didn't expect you to be able to read this text, by the way, but apparently it's probably somewhat legible. But their focus was really on saying, look, building machine learning models requires a lot of manual work, right? How can we make this process easier? Well, we know that when you're trying to build something, right, instead of even a narrow use case, there's still a lot of, I wouldn't say boilerplate, but there are some known permutations that are certainly possible. Well, what if we could build a neural network to generate a machine learning model, right? And that's what AutoML is. So we've taken AutoML and we've applied it to Vision. And now what we can do is you provide labeled image data to us. We can actually build a machine learning model and give that back to you. And so it's a machine learning model that's trained on your image data, and it's custom to you specifically. It's not shared amongst any other projects or any other customers. It's dedicated to just your use case. And what's even better is the same serving infrastructure that serves the Cloud Vision API serves your AutoML model. So that means when you make your Vision API call, by default, it'll use the standard model we've built for you. But you actually have an option there to change it to a custom model. And you can just highlight the custom model and the version you want to use, and it'll actually use your machine learning model that we generated on your behalf. And what's even better is, if you don't have labeled images, that's OK. We can actually help annotate them for you as well. So we have a lot of the capability that you need, again, to build something very specific. Now, what I will often tell people in the real world is, the Vision API might get you, the stock Vision API might get you 60, 70, 80% of the way, and there might be that last 20%. But let's figure out what that is first. So don't invest too much time if you don't have images quite yet. Let's try the Vision API as it is. And if that's not a good fit, then we can move on to AutoML. So if you look at the breakdown of usage, right, in a really simple scenario here, I've got images, and I want to pass them through a classifier that's very capable. Right on the bottom, I've got the stock Vision API. And on the top, I've got the AutoML Vision API. And again, the only distinction here is that AutoML Vision needed one additional input, which was a bunch of labeled images up front. After that, they look, feel, and function in exactly the same way. All right, so what about the messaging component, right? How do we notify an associate or a team member on the floor that they've got to go restock? Well, that's where Firebase comes in. Firebase is our complete sort of mobile backend as a service. And I'm not going to go through all of what Firebase has, but imagine, right, a system for authentication, complete SDKs for Android and iOS, and it actually supports web applications as well. It gives you real-time database synchronization behind the scenes. So it's got a whole bunch of functionality, and I haven't even touched on a good portion of it, but a whole mess of functionality that you can use to build mobile applications. And one of those key features that we need to leverage in this case is messaging. So built-in push messaging support, and that's what I'll use here. And actually, that push messaging also supports the web, which I will show a little bit later in my demo for you. All right, so we've gotten the four main pillars on the outside, right? Containers, storage, the classifier, the messaging component. What about orchestration, right? How do we actually make this thing run together? And turns out it's a handful of components, not just one, but the core of it is some kind of an application platform, right? Whether that's Cloud Functions, App Engine, Kubernetes Engine, or Compute Engine, right? You've got four main options here that we need to run some kind of a compute mechanism or some sort of set of applications and services to actually shuttle this stuff all the way through Once those images land in storage, they've got to get to the classifier. Once they get to the classifier, we've got to parse those results back out and decide if we want to message, and then keep that whole machine running. So I won't go into too much depth here. There have been a number of sessions yesterday and probably some more today and tomorrow around the different compute platforms, but at an incredibly high level. Cloud Functions gives you the ability to run serverless functions, right? Just like you'd expect. And those can be either in Node or Python. App Engine lets you build more full-blown apps or services and lets us help you scale them automatically based on incoming traffic. Kubernetes Engine is a level deeper than App Engine, where you have the ability to basically run containers and manage them at scale across a larger number of machines. This is where the applications might get more complicated. They may have more features and functionality. And then finally, we give you really fast VMs in Compute Engine. So you have a few different options here. And I'll tell you, I think depending on the use case, one or another might make the most sense. I'm happy to talk through with any one of you about which one's the right choice. But for most production applications, most production deployments, we often see App Engine or Kubernetes Engine because they have a fair amount of capability and a lot of knobs that you can still turn to make things work the way you want them to without giving you too much on the Compute Engine side and maybe not being too limiting like you might run into with Cloud Functions. All right, so let's put this all together and see what it looks like. So the biggest thing I would say for, again, typical kind of production use case is with AutoML Vision, right? A trained model based on your images and your image data, and then either App Engine or Kubernetes Engine, and using Firebase, right? So those are really the four tentpole components that we need to use. So if we dig into an actual kind of rough production architecture that I would typically kind of suggest you would use in this case, what we have in the, about 100 feet up from me on the left there, capture and upload, right? So that's capturing those images, capturing that video in a store environment. That little control plane I talked about earlier, that local device that's going to pull those images off and actually package them up and send them to the cloud. That's that little upload device there. And then it lands inside a GCP. And once it gets to GCP, we've got a handful of boxes and components here to really drive this and make it happen. So the first thing we do is those images land inside of Google Cloud Storage. And Cloud Storage actually has this really awesome feature called bucket change notifications. And what that means is every time you upload an object or you delete an object or you change metadata in an object, it can actually generate notifications for you or generate messages for you. And those messages can go to a number of downstream targets. The two most popular are either Cloud PubSub, our messaging infrastructure, or Cloud Functions. In this case, I chose Cloud PubSub, and I'll come back to why I made that choice. But what I've done here is every time a new image is uploaded into this bucket, it fires off a bucket change notification. That bucket change notification, that payload is actually packaged up as a Cloud PubSub message and sent to a topic. That Cloud PubSub topic has a push subscription on it, and that push subscription actually can send it right to a target immediately in real time. So in this case, what I've done is I'm showing it going to a Kubernetes Engine app, right? Just a service that I'm running in there called, let's say, process image. That process image service is actually going to make the call to the AutoML Vision service. It's going to pass the image along. Actually, what it's going to do is not pass the actual physical image. It's going to pass a cloud storage bucket location of the image. So I can just say, here's an image that's in cloud storage. Please analyze it for me. And it's going to give me back a JSON response. I'm going to run through that JSON response, look for what I need to, right? Any kind of restock message that I want to have in there. And then if we need to restock something, that process image service will send another message back out to a different pub subtopic, which has a push subscription to another service inside a Kubernetes engine. And that will decide to actually make the connection to Firebase and say, go ahead and send a push message to whichever devices are appropriate to get the message. Right? So it's a little bit of a back and forth here, but I did this for a couple reasons. Right? You could actually orchestrate this with probably a couple of cloud functions and a little bit smaller scope. But again, go back to the original example, right? Pretty big store with lots of cameras, a lot of stores. So there's going to be a lot of data generated off of those images, right? A lot of images getting uploaded, a lot of potential data getting analyzed there. So I picked PubSub for a particular reason, which is if you want to have the ability to fan out and say, well, I want to analyze a lot of these events, or I want to persist each of these incoming events as maybe time series for later analysis, or I want to drive a bunch of other maybe downstream workflows based on images being uploaded, or based on messages being sent, right, before they get sent out, you have the ability to do that with Cloud PubSub, right? A single topic in PubSub can actually have multiple subscriptions, push or pull. So that means I could have different applications that are going to take action on the message, or I could have different applications like a data flow pipeline that's analyzing the data coming out of that PubSub topic. So it gives you a lot of power and flexibility to change components and swap them in and out, or add more or less. So PubSub is a really, really powerful tool, and I don't think it gets nearly enough love. I think we should talk about it a lot more, in fact, because it's incredibly capable, right? It's this really, really powerful glue, and you can add lots of subscribers onto it with literally no impact on performance, no change for the most part. So this is like an example of like a production approach that we might take. Well, as part of this, I wanted to show you guys a little bit of a demo. So I want to show you how to put this together in kind of an example setup. So the first thing I needed, right, if we go back to that bananas challenge, was I needed some sample data to test against. Somebody sent me this photo they took a long time ago. This is me in a banana suit. This is actually not useful sample data for the test we're trying to do here. So not quite what we're looking for. So actually, this is the set of images I used as kind of a basis here. So I went into a Google Micro Kitchen, and I took the bowl of bananas out, took it back to my desk after I got some weird looks from a few folks, and I wrote this little note in there that said, restock the bananas. And I left it on the bottom, and you can see it's poking out a little bit in the middle image there. And I took these images with my phone, so it's not a completely accurate representation because I've got a pretty good camera on my phone. So I actually scaled them down to 2 megapixels and turned them black and white. And that's actually a pretty close representation of what you get out of a common camera. Color, black and white, I think that's just a minor cost piece, but 2 megapixels was sort of a good average at a low price point. So I started with this, and what I did was I tried to build as much of the production approach that I could. So with that, let me switch to my laptop here and show you guys. Perfect. Does that look readable to everybody? Thumbs. OK. I think we're OK. We'll go with it. All right. So in this directory here, and I've got Cloud Shell up and running. So this is inside my project. So what I've got 9 images. The bottom 3 are the original, 1, 2, and 3. So that was the first, second, and third. Right. The third has the note in it. And then I scale it down to 2 megapixels, and then I did black and white. And now, if I have already the bucket set up and the pub subtopic set up, so if I can show you, so I'm going to show you that the bucket itself is actually empty right now. Oops. All right, so we'll see the bucket's empty. So the first thing I'm going to do is copy in one of the out of stock images. So that's thank you. Never type in front of a crowd. Oops. All right. So what I'm basically simulating here is that local device taking an image and pushing it up to cloud storage. So I'm going to copy that image in there. And this is one of those out-of-stock ones. So what we should see in about a second, all right, can you see that little notification down there at the bottom? It says inventory update, time to restock the bananas. So in that time, what's happened is I uploaded the image to cloud storage, fired off a bucket change notification to PubSub. That PubSub topic delivered a message via push subscription to an App Engine app, in this case, for demo purposes. That App Engine app actually looked at the payload of that message and said, OK, a new image has been uploaded. I'm going to go ahead and throw that image to the stock Vision API. Vision API came back with a response and said, yep, I see text in there. It says restock bananas. So I fired off another message from that App Engine app to PubSub and said, go ahead and restock. Another App Engine app took over there and actually made the connection to Firebase and sent it off. So all that kind of happened in about a second. It takes about, I think, about a second for the first service, and then about a handful of milliseconds, less than a second for the second part. So first thing I want to show you is what that App Engine service looks like for the first part, so the process image component. So that's a little bit legible. So there's a little bit of boilerplate up here at the top. But I want to show that the purpose here is not to kind of go through a line-by-line read of this code, but really to tell you it's not terribly complicated. I spent more time putting, I think, comments and some log statements in. But really what I'm doing is just the first thing, when you set up that push subscription inside a pub sub, you actually give it an endpoint. You say, send the messages to this endpoint. So your endpoint actually doesn't have to do anything with the pub sub mechanism. It doesn't have to go pull from it or actually authenticate to that service. It just gets that as post payload, right inside that request function. And so now I get it inside the request data, and I can actually turn that payload, I can decode it, and I can actually turn it into a set of JSON and get the message payload back out of it. And once I do that, all I'm checking for to make sure is it actually, is this message coming from Google Cloud Storage, Just in case someone was able to get access. Just want to have a quick little debug check in there. But then I get down into what am I actually doing, So the first thing I'm doing is I'm extracting the image path, the full path of that image that was just uploaded. And then I'm actually creating a really quick call to the Vision API. And it's only a handful of lines. You'll see it starts right down here. First thing I do, I create a little client to talk to the Vision API. And then I tell it I want to annotate an image. I give it the source location in Google Cloud Storage. And then I ask it to do two things. Give me all the labels, so detect all the objects in the image and give me some labels and some confidence around those. And then let me know if there's any text in the image. So when I get that payload back, what I'm able to do way down here is actually iterate through all of the label annotations and all of the text annotations that the Vision API gave back to me and figure out, did it find anything around restock bananas? And so once I find that, yes, it did indeed find that text in the image, then I can send a message to Cloud Pub Sub and let the downstream services that need to take action, let them know that we've got to restock. And one interesting note here is if you set up a Cloud Pub Sub push subscription to an application, you're actually not going to return 200 OK. You actually need to return 204, which is an interesting little tidbit. But the purpose there really is to make sure that if you return 200 OK, it's actually not going to acknowledge the message, and it'll leave it in the queue. So you want to make sure that, yes, you process the message, you're going to take action, and I'm going to go ahead and acknowledge and make sure that message is no longer in the pub sub queue. So that's that service. And now if we look at the messaging service, it's actually even simpler. So same sort of boilerplate at the top here, but a couple things to note here is the first thing is I'm going to need access to the Firebase backend admin controls because I'm going to use that to send the actual downstream message. And what I'm going to do in the process message component really is just, again, it's a push subscription, so I just need to unpack the payload, unpack that envelope, and pull out the data that's in there. Make sure it says, restock bananas, and then go ahead and send a message to the Firebase messaging component, and it's actually going to figure out where to send it to. And so that setup of where to send it to, in this example, what I did is I built a simple little Firebase web app called Proactively Stocking Inventory, and that first little bit at the top is the instance ID. That's the specific ID of this browser so that it knows to send push notifications to. And so the way I got this up there, what you would probably do in a sort of a production scenario is, store this token inside of a database or some other component. What I did here was I just actually put it as part of the compute engine project metadata. So I was able to pull that token out and say, send it to any of the downstream targets that are in this metadata key. So I cheated a little bit for the purpose of the demo, but ultimately, it was able to figure out, I need to send it to this device, and that's where the notification came from. Now, what you're probably wondering is, does this really work, Did I just mock it up just so it always says restock bananas? And the answer is no, it actually does work, as you'd expect. So if I take another image and send it up there, whoops. So bananas 1 is actually the first image with the full bowl. So I'm going to copy that into the bucket. So we'll watch that go through. All right, so it's going to copy that image up there, and I can show you the logs viewer, but it's not very exciting. But effectively what's happening here is it's making its way through that architecture, through that process, and it's finding that, nope, there's no text that says restock bananas in there, so I don't need to send any notifications. So now if we switch back to the slides, I can talk you through a little bit of the architecture I chose for the demo purposes. Perfect. All right. So for this one, it actually looks relatively similar to the production version, right? I made a couple of little tweaks, primarily the use of App Engine instead of Kubernetes Engine. And I also chose to use the stock vision API instead of a trained custom model. And mostly because 3 images is not enough to train a complex custom model there. But ultimately, right, I took those pictures with my phone, I hand uploaded them myself to Google Cloud Storage, and the notification that fired back through came back through my web browser in Chrome. But the ends, so the beginning and the end of that are really specific to the demo here, but if you go back to the original, remember it's camera, local device to do the upload, and that's actually a phone or a handheld device on the other end from Firebase. And so really there'd be no tweak I'd have to do with most of the architecture because everything on the cloud side is actually pretty well set up like you would normally want it to work. It's just a matter of changing the upload, the input segment, and which device you're actually targeting. And those Firebase messages actually have the ability to be targeted across multiple devices, not just a single. So you're not sending a push notification to every single team member. You may have all of your folks running with a custom-built app there, and you may say, well, I just want to send it to the people who are subscribed to inventory updates. So now you have the ability to actually specifically target those that are ready to run back to the room and restock bananas and fill them in. All right, so where do you go from here? So streaming, and I mentioned this a little bit up front, but I think it's worth revisiting. I think streaming is an interesting approach, right? Instead of sampling, taking that raw footage and just throwing it up to the cloud, and maybe using, instead of Vision API, using the Video Intelligence API, right? The APIs are actually relatively similar in that, the Video Intelligence API functions much like the Vision API does, except it's looking at moving images instead of, or it's looking at it frame by frame within a large set of images as opposed to a single image. But it effectively functions the same way in terms of the label, object, face detection, that sort of thing. But you're back to, right, is it worth the investment to stream that data? Do you need to have the network bandwidth? Do you need to have a more capable device on-prem or in the store to actually send that data up? It might not be, right? It might, depending on the size and the scope of the deployment you're trying to put together, it might not be an appropriate fit. Well, what about shelf-based inventory, right? How do we see all the way through the back of a shelf? We could with shelf-mounted cameras. And it's actually a great partner of ours, Trax, who's over in the retail showcase in Moscone West, actually has shelf-based cameras exactly for this purpose. So they've actually got a really cool demo of stacks of boxes of donuts. And every time you pull a donut out, it updates the inventory count. So that actually could work for certain other use cases where, again, there's sort of narrowly kind of packed in items. You can't get overhead cameras inappropriately. They've got a good little shelf-based system, and it functions in a lot of similar ways to what I've shown you today. Well, what about a custom model? What if you want to go with something that we can't do with Vision API or AutoML? What if you need something incredibly more specific? Well, that's where you can use something like TensorFlow to build a very specific custom object detection model. And you actually run that on top of our Cloud ML Engine service. And so what the Cloud ML Engine service gives you is the ability to train at incredible scale and do things like hyperparameter tuning, which lets you specify which parameters in your model do you want to tweak and how many permutations do you want us to run them through. So we can actually take your model and say, well, let's run 500 permutations, tweaking each of those individual parameters and figure out which mix is the right mix of parameters for your model to be most effective. And that's actually baked into the service. And then, when it's done training, you can actually promote that model to production, and we give you a nice little prediction endpoint that we run and scale for you as needed. And that prediction endpoint can be integrated into any application. So that's one option. And then, if you need to get that machine learning work, really close to the edge for whatever reason. Maybe you've got a very custom use case. Maybe you want to layer in some very specific detection, and the latency to cloud is just a little bit too high, right? That could be it. That certainly could happen. Well, running machine learning models at the edge, running TensorFlow models or hosted TensorFlow, I would say it's not a non-trivial operation. It does require a fair amount of work. So we have a package actually called kubeflow, which takes all the components you need to run machine learning models and host them, and actually even update them there, and run it on top of any Kubernetes cluster. So you could imagine if you've got infrastructure inside the store, and you can deploy Kubernetes on there, you could actually take those trained models and just push them down to the store and run them in that environment inside of kubeflow. And it includes like notebook infrastructure, TensorBoard, and a bunch of other tools so that you can update those models in flight if you need to. And the last point, which is not on here, because it does come up, right? I'm going to go back a handful of images because I want to show you, is this approach that I showed today is actually based on stock being there, less, and then gone. But there's still some amount of time it would take for that notification to make it through, even if it's a couple of seconds. That's still time for someone to have to go get the notification, look at their phone, acknowledge it, go back to the back room, fill up a cart, and then restock the actual inventory. So this might not actually work for a lot of you, right? That's where, again, something like AutoML can really make the difference. Because you may supply images like this and say, well, for that middle one, we're going to label images like that as low stock. And maybe you want the notifications being generated by low stock, not no stock. So that kind of distinction is really only possible with something like AutoML, right? Where we need to get a little bit more fine grain than just general detection. You want to add a little bit more context to what you're seeing, and that's where something like AutoML can make a difference. So that specific kind of training approach. All right. So where do you go from here? What's the first thing you should do? I urge all of you, if you have not had a chance to play with Vision API, to go to cloud.google.com/vision and start uploading images, right? There's a nice little box on there and that page where you can just drag and drop, nice little HTML5 uploader, drag and drop an image on there and see all of the data that comes back out. It's incredible, right? You can see every single thing, and even if you remember back to those images of the banana and the bowl, when I did those results, and I probably should have pasted them in here, what's really cool is it told me, it had wood in there, and it had a reasonably high confidence that there was wood in the picture, as well as the bananas in there. It actually was able to read the stickers and tell me what was on the sticker. And it gave me not only the amount that it saw of the colors in both those things those objects it found, it also gave me the confidence that it had that those were the actual individual objects. So it gets really, really specific, and it's a really powerful tool, right? And it's actually capable of doing things like specific brand detection as well. So if you take a picture of like the Starbucks logo and you upload it, it'll actually tell you without even seeing the words that it's a Starbucks logo, or the Nike swoosh on the side of a shoe. So it's a pretty incredible capable API because it's been trained across the library of images that Google has access to, right? So that's the thing I would start with, right? Go through that, upload an image, look through all the results, look through what you can find, and throw kind of crazy things at it, right? Because it's a lot of fun to see what you might be able to build, what you may be able to do with the data that comes out of those images. There's so much hidden in there that I think we might take for granted. The second thing I would have you do coming out of this session is check out some of these other ones that are coming up today and tomorrow. So injecting AI into your applications, I think gets more specific around each of the pre-trained machine learning APIs that we have as part of GCP. The vision session actually goes into specifically the stock vision API as well as the power that Cloud AutoML gives it and where you can supercharge it. Then there's also intelligent image analytics infrastructure, and that goes, again, a level deeper into more and more of those use cases. And then the last one is hybrid machine learning. That actually talks a lot about kubeflow and running kind of in Kubernetes environments, whether at the edge or in your own data center. But it goes into what does that machine learning lifecycle look like, right? What if you wanted to train on the cloud and then take that trained model and run it at the edge or run it in your data center, right? So we give you those capabilities. So those are some of the sessions I would strongly urge you to check out. And the last thing I would say is, if you've got questions, I'm happy to take some questions here because we've got a little bit extra time. There are 2 mics at the end, or you can yell it out, and I will try to repeat it best I can. And then the second request I have for you is, by all means, take the survey. Let me know what you liked, what you didn't like about this session. because I'm happy to do better next time. Thank you.